Okay, today it's a review. It's a review for the test. We've gotten through a lot of topics, like here's some. Everybody write these down. This will help you remember what's on the test, what topics are there. Domain. Do you remember doing domain questions where we'd take square roots and then we'd set them greater than or equal to 0, and we'd take the denominators and we'd set them not equal to 0? Remember that? That's domain. Okay, next topic, odd and even. I told you what pictures they look like, like the shape of an odd one on a graph and the shape of an even one on a graph. And I also showed you that algebraic way to figure out stuff is odd and even. I'm going to do practices on all of these, but next is a domain and range from a picture. So in other words, if I say, here, sketch this, and then tell me its range, you have to be able to go, okay, I know what this looks like, and I'll be able to tell you its range once I've sketched it. Okay, next topic is horizontal and vertical asymptotes. And do you remember that Bob tells you y? He tells you the y equals 1. And also on that, I gave you dumb ways to remember it, the horizontals and the zerticals, to try to remind you when I say what are the horizontals, I don't want you to by accident put the wrong ones in there. The horizontals are the y ones. That's why I call them horizontals. All right, and then the last thought is there are 12 functions you're supposed to know, but on the test, you are only going to be responsible for the ones you already learned from higher algebra. So those 6 that I already talked about with you guys, those are the ones you need to know. Okay, I'm not going to be expecting you to do one of the new ones, which is like the basic logistic function, which looks like, oh, I'm wrong actually. It looks like a basic logistic would not be on there. You'll have to do those later in the year, but that's one of the new functions that I haven't talked with you enough about. We'll talk about those later. Right now, let's focus on what you need to know for the test. All right, so let's do a few practice problems. First of all, domain. Remember, I've told you before, if you can factor it, you should. This is a tough one. There are a lot of things you have to solve. And then when you're all done and you found, you're going to set them all on this number line and say, oh, these are my 3 things. It works here, doesn't work there, etc. And all of a sudden you'll have shaded in like this kind of thing. And you'll say it works from here to here and there to there. Your answer will be written kind of like one of these things. Blah, blah, blah. Okay? So, go ahead. I'm going to give you a minute. See if you can solve that one without my help. That is a tough one. That's like an R3 level. Okay, I'm just going to show you how to start now that you've had a chance to work for a minute or two. In case you're stuck, remember, if you can factor it, you should. So I'm going to factor that. Square root of x plus 1, x plus 1. This is why I say those basics. You need to have them down, because now this has to be the easy part. X plus 2 and x minus 2. Okay, there, it's factored. Raise your hand if you got it factored right. Okay, good. Next step, you set what's underneath the root greater than or equal to 0. X plus 1, greater than or equal to 0. So do you get that the important spots are -1 and -1? So -1 is obviously one of the numbers on your chart here. All I'm doing is right now finding the important numbers. From there, I'm going to do my checking later. Okay, now I've got another important number for this. What would make that 0? -2, and what about that? +2. So I have -2 here and +2 here. There, I've got all my important numbers. Now, can it be -2? Go back to the original. Do you get if I have a -2, once it goes in here, it's going to make the denominator 0? So this it cannot be. Can it be -1? When I put a -1 in here, the denominator is not a problem. It's not going to crash. If I put in a -1 here, it's actually probably easiest to put it in here. It makes the top 0. Is that a bad thing? No, the top can be 0. It's okay. So this works. -1's okay. Does not crash function. How about 2? Does 2 crash the function? Yeah, so we have to leave this empty. Now we test regions and see where this function works and where it doesn't. I'm going to test this little region, testing 3. If I stick a 3 in, all I'm looking for is, does it crash? I personally like to stick it into this function better. I'm going to stick in a 3 here and a 3 here. Does the top crash? No. Do I stick in a 3 here and a 3 here? Does the bottom crash? Nope. All right. So all I'm looking for is crashing. With domain, we don't care. We don't care if it solves it. We just don't want it to crash. For a domain question, it's just good enough to just work. It works. Doesn't crash. Okay, now I'm going to test 0 because that's in this little zone. Put in a 0 here and a 0 here. Does the top crash? No. 0 here and a 0 here. Does the bottom crash? Nope, doesn't crash. Doesn't crash. It comes out to a number, so it worked. Works in here. Okay, now let's test -1.5. That's what's between -1 and -2. If I put in -1.5 right here, -1 1/2. Put that there, and I put that there. I will have a negative times a negative, which makes a positive. And so a square root of a positive is an okay thing. That doesn't crash. If I put in -0.5 here, or -1.5 and -1.5 here, it doesn't crash. Holy cow, works here too. Now the last thing I got to check is some big negative numbers, like -3. I'll see if that crashes it. The denominator can be negative, don't worry about that. But if I stick in a -3 into the x, then I have 9. 9 minus 4 is 5. Didn't crash, no problem there. If I stick in a -3 in here, I'll have a negative times a negative, which is going to make a positive. So once again, doesn't crash. So all these regions work. This would be a huge answer. You'd say from -∞ until -2 it worked. Then it worked again from -2 to, that one worked, so I don't need to even identify it. I just say it worked this whole time, all the way until 2. Union with, then it worked from 2 to infinity. There we go. That was about as tough as it could possibly be. All right, let's give you more of a baby one. And if you can't get this one, I'm scared for you. Y equals, I'm going to make one that factors again. Okay, remember, if you can factor it, you should. All I want's the domain on this guy. Tell me it's domain, as in everything works except what? I'll pause while you work on that. All right, you should have factored this like this. Y equals square root of x plus 2 and x plus 1. So then we take what's underneath the root here and we set it what? Equal to 0 or greater than or equal to 0? Greater than or equal to 0. So x plus 2 and x plus 1 is greater than or equal to 0. Now, do you remember on a problem like this, you need to use a number line? See, the end of that is like a number line. I tried to use that as a way to remind you when you have an inequality, you want to do a number line. And what are the two important spots on your number line? -1 and -2. Now, everybody gets this far. Like, seriously, when I'm grading these tests, everybody gets to this part. It's all about the testing of the intervals that makes people get it wrong from here. All right? Now, can -2 itself and -1 itself work? Yes, because it says or equal to. And if you want to prove it, you can stick -2 in, and you'll find out it will not crash, but it'll turn into 0. 0 is not crashing, unless it's on the denominator. Okay, so that worked, and that worked. And now I just test around it. What did you find out? Did it work on the inside or on the outsides? All right, so I'm going to just double check one and make sure you're right. I'm going to test 0 and see if 0 really works. Put a 0 right here and put a 0 right here. I will have 2 times 1, which is 2, and the square root of 2 does not crash, so it worked. You're right. So if it works here, it probably works here too. Did anybody actually test a number in between? It's kind of tough to test -1.5, but you can. And if you do, when you test -1.5 here, and you test -1.5 here, do you get how this one will turn into a negative number and this one will be positive? So your net result of multiplying, there will be a negative number underneath the root, so it does not work in there. Okay, so final answer would be from negative infinity to negative 2 and negative 1 to infinity. Okay, was there a question, or did that answer the question? Or yes? Oh, thank you. You got me. Brackets, because these work. So yes, I should have brackets on those. Okay? Yes, sir. All right. I know that a lot of kids are missing today, and now the seniors are about to miss the rest of the hour. Make sure you tell people to watch the video because the test is tomorrow, and you want to do the review. So I'll pause for a second while the seniors take off. All right, so my seniors are gone now. We've talked about some domain questions. One more domain question I'd like to do with you because it's a little different than the others. Okay, so let's try this one. Y equals 1 over x plus 2 plus the square root of x minus 1. Now this one freaks people out just because there's two separate things. Well, you just put it all on one number line. So solve each of them, put it all on one number line. So just because there's two parts to the problem doesn't mean you do it any different. Okay, so what'll crash this part? Say it if you know it. Negative 2 crashes this part. Okay, so negative 2 is the one of the important numbers. Can it be negative 2? No, because the thing will crash. Okay. On this side, I'm going to set x minus 1 to be greater than or equal to 0. And then I say x must be greater than or equal to 1 then. So now 1 is obviously an important number. Can it work at 1? Yes, and it says to shade greater than or equal to 1, so I can go this way. Now, could I test that just to be sure? Yeah, I can test it. I can test the number like 2, see if 2 works. If I put a 2 in, does that crash? Nope. Does that crash? Nope. As long as it didn't crash, it works. How about in here? What's in between 1 and negative 2? My favorite thing, 0. So if I put in a 0, does this one crash? No, it turns into 1/2. Does that one crash? Yes, it does. Because square root of negative 1 is not okay. Crashes. And then usually the other end will work on problems like this, but this time I don't think it does. Because remember how it had to be greater than or equal to 1? So I don't think negative 3 is going to work. I'm just going to check it. So I stick in a negative 3. Does that cause a problem there? No. Does it cause a problem there? Yeah. Negative 3 minus 1 will be negative 4 squared, and negative 4 is not allowed. There we go. So it really only works from 1 to infinity. Final answer. Bracket 1 to infinity. Raise your hand if you had that before I did. Okay, good. Any questions on that? Okay, that's enough about domain. It's an important thing, but we have a lot of things to cover. Now let's talk about, sketch this for me. You need to remember these from higher algebra. Sketch that for me. Because the reason you need to sketch is not because we're graphing testing you, but because we're going to ask you what's the range. And if you can't get a picture, there's no good way to answer this question. You can do domains algebraically, but you can't do ranges. Or if you can, we don't teach it to you, so you won't have a chance to do it that way. So do you know that the parent function of this guy looks like this? Raise your hand if you knew that already. Okay, good. Then, if I do this negative on the outside, remember it's high, low. It's horizontal on the inside, but vertical on the outside. That's on the outside, so it's a vertical flip. To make this a vertical flip, it should look like that. Then, what's that plus 3 mean? Left 3 or right 3? Left 3. Your graph should look like this red one. The blue one was the parent. I'll just set it aside now. There we go. There's my graph. Now, what's the range? Well, range is the y values. So I'm going to, on the y axis here, I'm going to say I can go from here and then all the way down, but if I do it that way, I will get it wrong. Because it's the range has got to be from the lowest to the highest. So I can't say from 0 to negative infinity. That's wrong. I got to say from negative infinity to 0. negative infinity to 0. Look at your answers on all of these. Anytime you have intervals, if you ever have the smaller number last, you're doing it wrong. It should be smaller number first, and then the bigger number. Okay, so that's the right answer for the range. Range is that. Okay. Let's do one more, except you just do it this time. Okay, tell me the range of y equals negative, absolute value of negative, x plus 2. There's no plus or minus because this is an absolute. Okay, I get what you're thinking. Range, though, all we need to do is sketch this graph. You know these absolute values look like a V shape, right? Don't think about solving this with algebra. Just think about it as a V shape. It's been moved and flipped, and once you have the picture drawn, your range will be easy. I'll pause for a second while you work on that. All right, here's a V shape to start with. Then I flip it left, right, and up, down. The left, right flip does absolutely nothing. The up, down flip does do something. That makes it look like this. Then I just have to move it, and that plus 2 means left 2. So I'm going to go 1, 2. There. I'm assume that's 2 spots over. Then what's the range? From negative infinity to 0. Raise your hand if you had that one right. Okay, good. All right, so that's range from a picture. Now let's talk about, we did a lot of stuff with odd and even. And first thing I told you was how they look when they're even. So tell me, is that thing even? Does that have even symmetry? Pick up. Does that have even symmetry? Yes, it does. And if it has even symmetry, then if it has the point right here of 8, 6, what do you know has to be on that one? 8, 6 kind of, but what is it? Negative 8, 6 would have to be on this one if it truly has even symmetry. Does that make sense? Okay, how about odd symmetry? Let's say it has odd symmetry, but I don't tell you where it's going to go. You can figure it out. You don't need to sketch it. Just tell me what other point has got to be on it. If it's odd, if you get it, would have to be down here. Because remember how it's a reflection through the origin? Okay, so maybe it's more like here. What point would have to be on it? Negative 8, negative 6. Make sense? Now I can finish the sketch here and kind of go, okay, it generally look like that. All right, so that's odd symmetry. Now, even and odd, without the symmetry part, if you just do this, I'd like you to tell me if this function is odd or even or neither. Remember that if it's odd when we do, or sorry, even, the f of negative x, when we stick in negative x, remember that's our first step here. If it comes out to f of x, the original function, then it's even. If it's odd, you'll stick in negative x, and you'll have to factor out a negative 1, and it will be f of x. Like that. That's for odd. Remember those rules for even and odd? Would you please try it by sticking in a negative x here. See whether this one comes up even, or odd, or neither. You're drifting. This can be the difference between an A and a B. Stay focused with me. I think you're too warm. Dressed all fancy. So I start by making empty spots. What do I drop into them? Miri? Close. Negative x. Okay. When I do that, flash, what do you get? Cubed plus 4x, yep, minus x. Good. And what did we just do there? We just did f of negative x. And when we are done, is that the same as that? No, it's not even close. Okay, so it's not, right there you should say not even. Okay. Next step, what do we do? Remember this? Factor out a negative 1. And then let's see what we have. X cubed minus 4x plus x. You see how picky this is? All it's going to take is that one sign being off. You know what I mean? If I factored out the negative correctly, now you can tell by multiplying it back out, like this times this times that. Did I factor it out correctly? Okay. Is this the same as this then? No. So it's really close to being odd, but it's not odd. And therefore, neither. If you just say neither, I will have to mark it wrong. You have to say first, prove it's not even, then prove it's not odd, then you can say, therefore, neither. If you just try to jump right to neither, no credit. Got to show me. Because these are proofs. This is not just, you know, like, is it even or odd? It's prove that it's even or prove that it's odd. And so to prove something's a neither, you have to prove it's not even and prove it's not odd. All right. One more that's a little simpler. I'll tell you this is even, but I want you to prove it. Use f of x. Write legibly so somebody else can read it. All right, what I want to do here is have your iPad get graded by somebody. So what I'm going to do is the person forward and like a forward back thing. So would you move back 2 seats just for the next few minutes right here? And then you two are going to hold your iPads up side by side and you're going to compare them. And you're going to see if there's any differences. You two are going to compare them side by side. See if there's any differences. You two. You two, compare your iPads side by side right now. You two, and you two. Compare them side by side. Make sure you have the same, everything the same. I'm talking like every negative is in the same spot. There's really only one right way to do this. All right, here's what you should have done. F of negative x. Everything there's no optional other way to do this. This has to have a parentheses. Can you skip the parentheses? No. Technically, if you just, what's the difference? If I stick in negative x now, then the answer is positive x squared. If I do this, though, without the parentheses, negative x quantity squared, that answer is actually negative x squared. Do you get the difference? You have to have the parentheses. If you didn't, you would be marked wrong. I've always told you, replace the x with an empty parentheses. And this would be an example of a time where if you didn't, you'd be wrong. Okay, so then, next step, f of negative x is equal to positive x squared plus 6. And that's the moment where that and that are showing you that f of x and negative f of x are equal. And you can say, therefore, even. All right, so there is a simple one, but yet I'm showing you every little space. You got to write these carefully. I'm grading the work. I'm not just looking for, oh, I said it was even. I'm rating the work on this. Okay, next kind. Talked about odd and even. Let's talk about Bob. Bigger on top, bigger on bottom, same on both. Remember all those? Vertical asymptotes versus horizontal asymptotes. All right, first thing I want to see if you remember is, if I ask you to write vertical asymptotes, and I ask you to write the horizontal asymptotes, Just tell me what letter should be going in each blank. Don't say it, write it on your iPad. The verticals are this kind and the horizontals are that kind. If you haven't got those straight by now, we got to get it fixed. Test this tomorrow. All right, did you say x equals things go here and y equals things go there? And that's vertical. I'm going to morph my v into an x, vertical. And horizontal, I could almost do this with a y on my horizontal. Do you get, if I turn it over, it's like an h for horizontal. All right, just doing lots of things to keep you from making that dumb mistake. Because see, if you reverse these two, I mark them all wrong. And then that hurts. A lot of times you've already made your dumb mistake. And now this one costs you a whole grade. All right, so make sure you keep those straight. Now, how do we do the x ones? The x ones come from the denominator. The x ones, it's all about the base. Just like the song. Actually, let's make the top one x plus 4, and that way they won't cancel and get all complicated with holes and stuff. This one's just what's the domain. And what the domain kind of tells you, what are the asymptotes. And there's x asymptotes and there's also y asymptotes. But for right now, let's figure out those x ones, which are the vertical or vertical asymptotes. And they're all about the base. All right. So hopefully you knew it was x equals 3 and x equals negative 3. Because those are the two things that would crash your function. And when they're crashing the function, they're making asymptotes. Does that make sense? How many of you had that right? Okay, good. Now the horizontals. Ask Bob what the horizontals are on this. Bigger on bottom, bigger on top, same on both. What is it? What is it, by the way? This is a Bob. So what's the answer? Gotcha, 0. Oh, I have the people write that, and I go, oh, painful, and I mark it wrong. Y equals 0. Not none. None is a different thing than 0, and it's good to bring it up. But none would be if it was a bot. This is not a bigger on top. This is a Bob. And the rule for Bob is y equals 0. If you haven't got those straight yet, let me write them down quick. Bob is y equals 0. Bot, there's no or none on bots. There's no bots, like robots. By the way, I read an article the other day that by the year 2025, which is coming pretty fast, like 10 years from now, they say 1/3 of all jobs will be done by robots. The robot industry is advancing so quickly, and obviously they don't have to buy health insurance for robots. You know, they don't have robots ever take sick leave. Robots don't ever have babies, and you have to pay for them to stay home while they're raising their babies. So you can see why companies might like robots. There's lots of good things about them. 1 in 3 jobs are going to be robots. That was a scary number for me. I don't picture a cyborg teaching you, but I can picture a cyborg being the computer having a big role in your education. It's obviously getting a bigger and bigger role with the iPad, but I doubt we could just put you in a room with a computer and have it educate you, and at least yet. Maybe someday. Seriously, you could maybe do that if you had a smart enough computer. Okay, anyway, bigger on bottom, bigger on top, same on both, is y equals a ratio of the lead coefficients. That's one of the harder kinds. Okay, so let's try one of those harder kinds. Same on both kind. So let's say I have x to the third plus 3x to the fourth all over negative x to the fourth. Would you agree it's the same on both? So then figure out the asymptotes. In fact, figure out both the vertical and the horizontal asymptotes for me. I'll pause for a second while you try that. Okay, verticals. Is it those to be x things or y things? So what do you think? X equals 0. It's all about the base, right? What would crash that? Only 0. Very good. Okay, how about the horizontals? Mari. Is this bigger on bottom, bigger on top, or same on both? So what's the deal for SOBs? 3/1. You used the ratio of lead coefficients and you said negative. You're right. Doesn't matter where the negative is. I can put it there or I can put it on the bottom, but there needs to be one negative. And then you really should simplify that and just say y equals -3. Okay, why'd you pick the 3 and not the 1 that was in front of that? Because it's not just because it's bigger. There you go, because that one was bigger, and that means that's the lead coefficient. That means I should use the 3. Good. 3 and the -1 comes from down here. That's where I get these, and then the answer is -3. All right, one more. See if we can handle this one. Yes, question? Okay, the vertical asymptote is all about the base. What would make the base here be 0? What number could I put in that would make my base turn into 0? Yep, that's why it's 0. Yeah, here's a more normal one for that. Say you give it to you and then you got to factor it and it's all factored now and it looks like this. What's the vertical asymptotes? Everybody figure this out. Shouldn't be hard for you. What's the verticals? Then, just for fun, the horizontals, Bob will tell you very easily. Okay, the verticals, it's all about the base. That x equals -2, x equals 5. Those are the two things that would crash it. They make asymptotes. When you say it crashes it, what it means is there's an asymptote on the graph there. Okay, and then it also means the 0 on the bottom here. The horizontals is a bob. This is bigger on the bottom because the degree would be degree 2 on the bottom and degree 0 on the top. Technically, there's an x to the 0 right there. So that's why we know it's degree 0 on the top and degree 2 on the bottom. So it's bob, bigger on the bottom, y equals 0. There we go. Any questions on those? All right, that's a good review. Now, here's your worksheet. Got the rest of the time to work on that. I would strongly recommend you check the answers against the key. That'll be posted online. For those of you that missed class today, I really recommend that you do this thoroughly. Not a super easy test. A lot of chances to make dumb mistakes on this one. So do your homework and check it.